When we want to measure the amplitude or frequency of a wave, one of the common methods to use will be to use a cathode-ray-oscilloscope, otherwise known as a CRO. For example, if we have a sound wave whose amplitude and frequency is to be determined, we would use a microphone that is connected to a CRO. The microphone will actually pick up the sound wave and convert the sound wave into voltage signals. From there, the CRO will display it as an alternating voltage waveform from which the amplitude and frequency can be determined. The waveform is seen as a trace on the CRO screen, similar to this. There are two important settings to know for a CRO, which is the time-based setting and the wide gain setting. Together, they will determine how big the trace will look like on the screen. In other words, it determines the scale of the trace. Firstly, the wide gain setting allows the trace to move vertically, and it determines the vertical length of the trace. It is usually expressed in volts per centimeter or volts per division. Secondly, the time-based setting allows the trace to move horizontally and determines the horizontal length of the trace. It is usually expressed in milliseconds per centimeter or milliseconds per division. Next, let's review the effect of switching on and off the time-based setting and wide gain setting on the trace seen on the screen. If the time-based setting is switched off, then the trace cannot travel horizontally. If the wide gain setting is also switched off, then the trace cannot travel vertically too. The end result is that we only see a single dot on the CRO screen. If the time-based setting is switched on, then the trace can travel horizontally, but if the wide gain setting is off, the trace cannot travel vertically. The end result is that we only see a horizontal line on the CRO screen. If on the other hand, the time-based setting is off, the trace cannot travel horizontally, but the wide gain setting is on, the trace can travel vertically. We will only see a vertical line on the CRO screen. And lastly, if both the time-based setting and wide gain setting are switched on, the trace can travel both horizontally and vertically. We will be able to see a complete waveform as shown. Previously, you may have learned that period is the time taken for one complete oscillation, whereas frequency is the number of oscillations per unit time. In general, to determine period t and frequency f, we would be using the equations below, where we say that period is equals to the total time divided by the number of oscillations, whereas frequency is the reciprocal of the period, giving us number of oscillations over total time. In the example below, the trace has a time-based setting of 10 milliseconds per centimeter, whereas the wide gain setting is 5 volts per centimeter. We are interested in finding out the amplitude as well as its frequency. This line here represents the equilibrium position. So this would be the amplitude, whereas this would be the period. Notice that the box here measures 1 centimeter by 1 centimeter. So the amplitude occupies 2 boxes, giving us 2 centimeter, whereas the period occupies 4 boxes, giving us 4 centimeter. To find the amplitude now, it will be equals to 2 centimeter multiplied by 5 volts per centimeter, giving us 10 volts, whereas the period will be equals to 4 centimeter multiplied with 10 milliseconds per centimeter, giving us 40 milliseconds. Lastly, to find the frequency, it is the reciprocal of the period. We change the milliseconds to second, giving us 1 over 40 times 10 power minus 3. The final answer would be 25 Hertz. For the same wave, if the time-based setting was increased to 20 milliseconds per centimeter, double the previous value, then the period of the same wave will only be represented by 2 boxes horizontally, as shown here. Similarly, if the wide gain setting was increased to 10 volts per centimeter, double the previous value, then the amplitude of the same wave will only occupy one box vertically, as shown here. If we were to look at the earlier trace and the current trace, we can see that increasing the time base and Y gain setting has the effect of squashing the tracing. Conversely, we can also say that if we were to decrease the time base and Y gain setting, it would have the effect of stretching the tracing.